Today our lesson will be a review of factoring. We're going to start with the do now, which is to multiply and simplify each expression. So if I take 4x squared and I multiply it by x cubed minus x plus 2, I'm going to distribute each term onto each term in the set of parentheses, and I'll get 4x to the fifth, because when we multiply like bases, we add the powers, minus 4x cubed plus 8x squared. Okay. So this would be our factored form, and this is called standard form, just to remind you. In the second example, we have two sets of parentheses. So with this, in this case, we're going to FOIL. We want to multiply first times first, 2x squared, my outside terms, plus 4x, our inside terms, plus 5x, and then last times last, plus 10. And then we can combine our like terms, and we get 2x squared plus 9x plus 10. Once again, this is factored form up top and standard form on the bottom. And I know a lot of you can do this middle step in your head, and that's perfect. Okay, I want you to be able to do that. So today what we're going to do is we're going to review all of the methods of factoring you have learned in your previous classes. Okay, factoring is the opposite of multiplying expressions. So that's why I started with this do now. Okay, so now we're going to go work backwards. We're going to take the standard form and break it up into factors. To factor an expression is to write it as a product of other expressions. Factoring is used to simplify expressions and solve equations. Factoring is by far one of the most important skills you will use in math. It is your job to know all of the different methods of factoring and being able to recognize when to use them. Okay, so methods of factoring that you guys already know: greatest common factor, or GCF. So whenever you're looking at a problem, you always want to start by seeing if there's a greatest common factor in your expression you're trying to factor. So in this case, we have 2x cubed minus 4x squared. So I look in each term. In each term, I have a 2, and then I look at the variable part, and my GCF would be 2x squared. So I factored out the GCF. I'm going to open up a set of parentheses, and I kind of say in my head, you can divide it out, or you can say, what would I have to multiply 2x squared by to get 2x cubed? And that would just be an x. Minus, just bring down that minus sign. And again, what would I have to multiply 2x squared by to get 4x squared? And that would be a minus 2. So this would be factored. X cubed minus x squared plus x. Again, start with always GCF it. So I look, I have x cubed, I have an x squared, and I have an x. My GCF here is an x. Open up your set of parentheses. I'm going to be left with x squared minus x plus 1. Now, this set of parentheses is a trinomial. We're going to review that method in a few minutes. Most of you would already be starting to try to factor this. You can't. This factor is called a prime factor, and when that happens, you just leave it alone. Okay? So that's okay. Now, another method you already know is difference of two squares. So our rule for a difference of two squares is if you have an x squared or an x to the fourth or x to the sixth, whatever the case may be. So if you have two terms that are both perfect squares, they're going to break up into two sets of parentheses, whatever the square root of the first term is, plus the square root of the second term, and x minus the square root of the second term. So it's always going to be two sets of parentheses, x plus a, x minus a. First one's super easy. I'm doing this on purpose. So I would say, oh, that's a perfect square, that's a perfect square. Two sets of parentheses, x plus 2, x minus 2. And there you have it. It really is that easy. In the second example, I have 36x squared minus 9. Okay. Now this is two perfect squares. However, we have a GCF, so always, always take out your GCF first. In this case, my GCF is a 9. And I'm going to be left with 4x squared minus 1. The 9 stays. Okay, that's still a factor. Remember, we're breaking this into factors. Now, I think in my head, 4x squared is a perfect square, right? That's 2x. 1 is a perfect square. That's 1. So my two factors are going to be 2x plus 1 and 2x minus 1. Okay. And we're not trying to make anything difficult here. We're trying to get you to see and just feel comfortable and, work our way into the year with some easy stuff you already know. Our trinomial factoring, okay? You've been doing this for years now. I refer to trinomial factoring as double bubble. So how to recognize when you're going to be doing trinomial factoring is when you have three terms in the form of ax squared plus bx plus c. And the first method we're going to review is when our lead term, our a value is 1. Okay. So basically what we're going to, try to think of, we're going to set up two parentheses, right? Always bring down the x, but we're always going to look for now two numbers that multiply to c and combine to give you b. And by combine, I mean add or subtract. So I would look over here, and then also another thing we have to be aware of is our signs in our trinomial. So I'm going to set up my double bubble. I have x squared, so I'm going to put an x in the first spot of each set of parentheses. And now I think of two factors that multiply to 25. And this one's pretty easy because right away I could have 5 times 5, 25 times 1. Obviously, which one of these is going to work? The 5 times 5. Okay, so we want to multiply to a positive 25. So they're both going to be positive inside. And I get x plus 5 times x plus 5. We could also write this as x plus 5 squared. Okay. In my class, pretty much either answer here would be acceptable. Okay. For number 2, it's going to be three terms, right? ax squared plus bx plus c. So I have a trinomial. I'm going to double bubble. I put an x in each spot. And now I want to think of two numbers that multiply to -8 and combine to give me -2. Okay. This is going to be negative, so I know that I'm going to have one set of parentheses is going to be positive, one is going to be negative. And it's pretty obvious here. We're going to be dealing with 4 and 2. Okay. My middle term is negative, so the larger factor is going to be in the negative spot. So I have x minus 4 and x plus 2. If you don't trust yourself, just work backwards. X squared minus 4x plus 2x, that's your -2x. 2 times -4 gives you -8. So you can always kind of check yourself. X to the 4th minus x squared minus 6. So now my highest power is not x squared anymore. But if I take and I write x squared and x squared in each term, when I multiply these two together, I am going to get x to the 4th. And a little hint here, if this is going to be able to be factored using this method, this term will always be, the middle guy is always what goes there. So now I have x squared and x squared, and I need to think of two numbers that multiply to -6 and combine to give me -1. So I'm thinking I have 3 times 2. I have 6 times 1. So I'm thinking some sort of using the 3 and the 2 is going to work. I'm negative, so I'm going to have a positive and a negative factor. And since my middle term is negative, the larger factor is going to go with the negative value or in the negative term. So let's just check this out. X to the fourth, negative 3x squared, positive 2x squared gives me negative 1x squared. 2 times negative 3 gives me negative 6, so we're good to go. Now we're going to move on to our tricky trinomials. Our tricky trinomials are in the form of ax squared plus bx plus c, and a doesn't equal 1. So in this case, we're going to use either the rainbow method or the bridge method. Teachers refer to this in different ways. So what I do here is still set up 2 sets of parentheses. I'm going to bring down a 2x and a 2x in each of my set of parentheses. Now I know when I multiply 2x times 2x, I do not get 2x squared. Okay? So I kind of am cheating right here. I'm going to account for that later on. Then I go here and I multiply and I get a 6. So I need 2 numbers that multiply to 6 and combine to give me 5. Once again, that's going to be 3 and 2. Both positives. So I'm going to put the 3 and the 2 here. Now I'm not done because I cheated, okay? So I put a 2x in to begin with. I have to take it out. So I'm going to go into the factor. That is divisible by 2. And I'm going to get rid of that guy. And now I have 2x plus 3 times x plus 1. And if I FOIL this out, I would wind up getting 2x squared. 2x and 3x gives me 5x. 3 times 1 gives me 3. In the next example, 6x squared plus 5x plus 1. My double bubble. 6x, 6x, 6 times 1 is 6. So once again, I need 2 factors that multiply to 6 and combine to give me 5 and are both positive. And that again is going to be 3 and 2. Now in this case, this is a little tricky because I don't have one set of parentheses that's divisible by 6. I put in an extra factor of 6, so I'm going to divide this one by 3 and this one by 2. And here I would get 2x plus 1, 3x plus 1, and check it out, 6x squared plus 2x plus 3x gives you the 5x, 1 times 1 gives you 1. In our last example, I have 4x squared minus 13x plus 3. So we're going to do 4x, 4x. 2 factors that multiply to 12 and combine to give me negative 13. So I want a positive 12 and a negative 13. So both of these are going to be minus this time. And that's going to be 12 and 1. I put in a factor of 4. I have to divide it out. X minus 3, 4x minus 1. 4x squared minus 1x minus 12x gives you the negative 13x. Negative 3 times negative 1 gives you positive 3. I know that some of you may have learned a different method in your previous courses. You are more than welcome to use it. I always mess that one up, so I kind of stick with this one. I just wanted to point that out because some of you may be saying, like, what is she talking about? So if you use the other method, that's perfectly fine. And, you know, you can ask me about it. I could try to relearn it, but I always mess it up and go back to this one. Next factoring method that you should know, sum or difference of 2 cubes. Some of you may, recognize this as SOAP. Same, opposite, always a positive. Maybe if I say that, some of you will know what I'm talking about. Always positive. So, how does this one work? All right, so if you're looking at something and if you're trying to factor something and you recognize that it's a sum of two cubes or a difference of two cubes, okay, the formula is very simple, similar for each one. Okay. So in each case, you're going to take and set up a binomial. And that binomial is going to be the cubed root of the first term plus the cubed root of the second term. That's what we mean by same. So you're going to do same sign. And then you're going to do, working off your binomial, your first term squared, opposite sign, first times second, always a positive, last term squared. And if it's a minus in between, so this works, a dots only works if there's a minus in between. The sum or difference of two cubes works in either case. Same sign. Now work off your binomial. First term squared, opposite sign. First term times second term, always a positive, last term squared. And there's your formula. So this, you sort of have to memorize. So if we want to try to factor x cubed plus 8, okay, so what I would do, I would go right down underneath it, set up your binomial. Cubed root of the first term, same sign, cubed root of the second term. Now I'm going to make my second set of parentheses, working off your binomial. First term squared, opposite sign. First times second, always a plus, last term squared. This piece here will never be able to be factored. Okay, so you don't have to worry about it. If you use your formula correctly, you're good to go. For number 2, x cubed minus 125. Again, set up your binomial, cubed root of your first term, same sign, cubed root of your second term. Now work on the trinomial piece. First term squared, opposite sign. First times second, always a plus, last term squared. And if you ever doubt yourself, all you have to do is distribute it. I'm not going to do it here because it's going to be too time consuming, but you would just distribute this out and combine like terms and you should get back to the original. Our last example, so 27x cubed minus 64. I look real quick just to see if there's a GCF. There's no GCF. But I do see that 27x cubed is really a perfect cube because the cubed root of 27 is 3, so that's 3x. The cubed root of 64 is 4. So really, I do have a difference of 2 cubes. Working off my binomial, first term squared, 9x squared, opposite sign, first times second, always a plus, last term squared. Okay, so there's a little bit of review on your sum or difference of 2 cubes. Okay. The last thing we're going to talk about today is going to be factor by grouping. And I know that in years past, they didn't really go into factor by grouping in previous courses, but now you do. So I know that a lot of you are familiar with this. You're always going to use factor by grouping when you have more than 3 terms. And basically, just to remind you, I usually factor out the common factor from each group. And combine what's left. As a binomial factor. There might be a better way to describe this. Okay. but this is basically like the best words I can come up with. So we're going to take a look at this first example here. I have 1, 2, 3, 4 terms. So in my head, would be saying, oh, I'm going to try factor by grouping. Always look to see if you have a GCF first among all of the 4 terms. Okay. If you don't, then you would kind of group together the first 2 terms, group together the second 2 terms. In my first 2 terms, my GCF here is x squared. And then I'd be left with x minus 4. Now I'm going to bring down this sign. And I look at my second set of terms. My GCF is a 2. So if I factor out a 2 here, I'm going to be left with x minus 4. And what's nice about this is you'll always get, if you do it right, a set of parentheses that are the same. Because actually this is a term and this is a term now. So my GCF is x minus 4. And what's left outside of each set of parentheses becomes its own little factor. And there's your answer. For our next example, 1, 2, 3, 4 terms, no GCF. So I'm going to break this up into groups. I GCF the first group, x squared, x minus 2. Bring down the sign. 9. Now think about this. I'm factoring out a negative 9. So I'm going to have x minus 2 inside. Now my GCF is x minus 2. And then my leftover is x squared minus 9. But this is a dots, so we're not done. X minus 2, x plus 3, x minus 3. Now we're done. And in our last example, I look in my first grouping. I have x cubed, x plus 1, plus x plus 1. Now this one's a little tricky, because now when I look here, right, I factor out my x plus 1. And technically, since there was nothing out in front, there really is a 1 there, right? So when I set up my next set of parentheses, I have x cubed plus 1. And now this is a sum of 2 cubes. So we get x plus 1, x plus 1, x squared minus x plus 1. Same, opposite, always a plus. And so we wind up with a nice, pretty factored form that looks just like that. Okay? So that's a little bit of review of factoring. I hope you found that helpful.